am Anna Marie Paragoso and welcome to my physics leisure activity video. Today, I am going to share one of my favorite simple yet relaxing things to do, throwing a stone in the water. Now, you might be wondering what does this have to do with physics? Well, a lot. This small and fun activity actually demonstrates one of the most interesting topics in physics, the projectile motion. In this video, I'll show you how I do it, explain the science behind it, and help you see physics in action in our everyday lives. So what are you waiting for? Let's get it! As I throw the stone, notice how it moves upward, slows down at the top, and then falls back down into the water. That smooth curve it follows is called a parabolic path, and that's the path of a projectile. It looks peaceful, but there's a lot of physics happening here. Now, let's talk about what actually happens when I throw the stone. When I throw the stone, I apply the force at an angle, not straight up and not straight forward. That angle is what determines how far and how high the stone will go. The motion of the stone can be divided into two. The horizontal motion, which is the x-axis, which shows that the stone moves forward at a constant speed since there's no horizontal force, and the vertical motion, which is the y-axis, that shows that the stone moves upward and then downward under the influence of gravity, which pulls it back towards the earth. In physics, the motion of the stone can be described with simple equations. The horizontal velocity with its equation Vx is equals to v cosine theta, and the vertical velocity with its equation Vy is equals to v sine theta, and the distance it travels or range represents by the capital R depends on speed and angle, which has the equation of R is equals to v squared sine 2 theta over acceleration. That's why no matter how you throw it, gravity will always bring it down. But by controlling your force and angle, you can control where it lands. These two motions happen simultaneously, and together they form the curved parabolic path we saw earlier. To better understand it, let's break it more clearly. So the initial velocity is the speed I use to throw the stone. Then the angle of projection determines how high or far it travels. The maximum height is the highest point the stone reaches. Then the range is the total horizontal distance it covers before hitting the water. And the time of flight is how long it stays in the air before landing. If I throw the stone at a higher angle, it goes higher but not too far. If I throw it at a lower angle, it travels farther but doesn't go as high. The perfect angle to get the farthest throw, in theory, is 45 degrees. Of course, in real life, things like air resistance, the shape and weight of the stone, and even how you throw it affects the motion. But the core physics principle remains the same. The stone follows a parabolic path governed by gravity and initial velocity. And every ripple you see is a reminder of the energy transferred from the moving stone to the surface of the water. Motion transformed into waves. So, that's how physics is connected with my leisure activity, throwing a stone into the water. It's more than just fun and relaxing. It's a real demonstration of how the laws of motion work around us every day. Through this simple action, we can understand projectile motion, gravity, and energy transfer in a natural way.